We move on to section 2.2, and this is talking about ratios and rates. And then we're going to eventually move into some solving proportions. So first thing is that we want to talk about what is a ratio. A ratio is just a comparison between two numbers. Those numbers usually stand for things that in the real world, like a ratio of like the score of a game. That would be a ratio. Number of students to teachers. That would be a ratio. And those types of things. So between two numbers or quantities. Yep. Comparison between two numbers or quantities. You could go with three numbers. You could compare three numbers. You could compare four numbers. But what we're going to be looking at is really just comparing two things. Well, ways that we can represent that. So if we had the comparison of 3 to 4, we would write it 3 to 4. We could write it like this with a colon in between. Or the most common one that we would write it as like a fraction like that. A couple examples, those were a couple examples as well, but let's say that we had some stars and circles. If I were comparing stars to circles, I would say that it would be 2 to 3. I could say 2 to 3 like this, or I could say 2 over 3 like this. And that would be fine. If we were talking about the number of students to teachers in our classes, it would be students would be there's 35 students roughly in each class, and teachers there would be 1, so it would be 35 to 1, or 35 colon 1, or 35 over 1. Ways that it's like a fraction. Well, first of all, it's a comparison, and it's often a division problem. And it looks like a fraction in the division form, like this. A division problem or a fraction is a part divided by a whole. So that's one way that it can be like a fraction. Like that. Often fractions don't have labels on them, and so that's one way that then they can be different than a fraction. We often talk about them with labels, and we will take that ratio and call it rate when we put some labels on it. And then often they're not part divided by whole. So in the case that we had with stars and circles, we had 2 to 3 stars to circles. That's not part divided by whole. That's two different things that we're comparing. Okay, so that it's not always part divided by whole. That's a pretty big difference between a fraction. Another way that it's different is that they have different ways to write. When we write a fraction, we usually write it with top number divided by a line and then a bottom number. When we write these, we can write them with the colon, or we can write them with the word 2 as well. So there's just different ways to write these things. Okay, so that's just a little bit of background on ratio. Excuse my technical difficulties there. It's called a proportion is an equality between two ratios. So I've got two ratios and I'm setting them equal to each other. That means that then they're in proportion to each other. If one goes up, the other one goes up, or if one goes down, the other one goes down. If we're looking at there's some sort of a relationship between the first ratio and the second ratio. And essentially what we're going to be looking for is what is the comparison, or what is the rule that happens. And when there's only this one problem up on top where I've got, like in number 36, I'm looking for just the x value, there's a few different ways that we could do this. The first way would be to look at the numbers that are together. So I've got a number here with 12 and 4, and I can look at, well, what did I do to 12 to get 4? Or what did I do to 4 to get 12? Well, if I took 4 times 3, then that gave me 12. So that means on top, I have to do whatever I did to the bottom of the fraction. This is just like reducing fractions when I have just this one variable. So I do 3 times 3, and x is equal to 9. Okay, so I can use logic to figure these out in the case where I'm just have a plain number there. So that means in like number 37, I'm taking to get from 6 to 2, I'm dividing by 3. Or if I look the other way, if I go from 2 to 6, I had to multiply by 3. So I multiplied the top by 3 to get to 6. I have to multiply the bottom by 3, and x just happens to be 9 again. Now, if that doesn't really make sense to you, then let's take a look at the more typical way that we're going to solve these. In a proportion, if I have a over b equal to c over d, if I have that, then a times d is equal to c times b. All right, so we can use that idea from this proportion. So that means that this is where we would end up cross multiplying. So I go x times 4, which is 4x, and 12 times 3, and just solve this nice one-step equation. So this is 4x equals 36, divide by 4, and x is 9. Same exact thing that we had this way. It just is maybe a little bit more of a process type way for some of you that need a process. So here's this one. We've got 6 times 3 is equal to x times 2. Well, x times 2 is 2x. 6 times 3 is 18 equals 2x divided by 2. And I also get that x is equal to 9. So x is equal to 9 down here, x is equal to 9 up here. Either way, it doesn't really matter how you think about it. I would, if I were asking you to do these problems, and you needed to absolutely pick a way to do them so that you could always do the problems the same, I would say choose the cross multiply way, because this is the reason why. Look at a problem like number 42. The question is, what did I do to go from 9 to 18? Well, I multiplied by 2. Well, that means that I have to multiply the 5 by 2 to get this number here. But the answer is not 10. X is not 10 in this problem. Okay, x is actually going to be 6, because I need this whole bottom part right here to be 10. I need the whole thing to be 10. And so the x part of it is 6, because I already have 4 of that 10. But if I'm using cross multiplying, this is what happens. I get 5 times 18, and then 9 times x plus 4. I put the x plus 4 in parentheses because I'm taking 9 times that whole thing. And so I get 5 times 18, and 5 times 8 is 40. 5 times 1 plus 4 gives me 90, equals, and then distributive property over here, I get 9x plus 36. Now I have a nice friendly equation to solve. I'm going to run into number 45 here, but you should do these on a separate sheet of paper so that you don't have that issue. 90 minus 36 is 54. Divide by 9. And then I still get that the x is equal to 6. Okay, so that work goes into the same exact type of problem here. I still get the same type of answer as I'm going through. Okay, but you need to make sure that you're understanding what we're actually looking for in terms of the x value as opposed to just multiplying the denominator. So that one turns into a nice friendly equation when we do that. But when I look at number 46, and I'm going to take this to a different page because it is a little bit longer than what we have here. So we've got x plus 3. Actually, let's just do this. Let's take a nice little picture. All right. So when I'm looking at this one, I'm going to end up with a much different process here. But the 4 times x still gives me 4x, and the 8 times this gives me 8 times x plus 3. Well, when I go through and do this, I get 4x on the left, and distributive property over here is 8x plus 24. Now I've got x's on both sides. In this case, I'm going to subtract the 8x just because I want it to get the x's by themselves. Divide by -4, and I get x is equal to -6. Now if I look at that to try to do it the logic way, I'm taking, it's pretty easy, I can see that I multiply 4 times 2 to get the 8. But what ends up happening up here is that I don't really have a number to be looking at to be multiplying this by. So I end up having to do a lot of extra work anyway. I have to do 2x plus 6 is equal to x, and then end up finding my -6 either way. So it requires you to still do this process even if you're using the logic way. So why not start with the process? But that's up to you. It doesn't necessarily matter to me. Some of you might have the back of this worksheet. We're going to take this portion of it and do a separate worksheet on it. So if you have the back of this worksheet, you can ignore it. But we are finishing or working on the front of this and doing the problems 35 through 50. And we're completing all of them. You should have 4 of them done just by watching this video. So good luck. Make sure you're asking questions when you're doing these in class.